Okay, today we're going to continue looking at complex numbers, and we're going to start with multiplication. So to multiply two complex numbers, use the distributive property to multiply each part of one number by each part of the other. We're also going to use the fact that I squared equals -1 to simplify the result. Okay. So here, probably using the distributive property, we actually have another name for that. We call that FOIL a lot of the time. So let's see what they did with this. So 4 times 6 is 24. Then the outside's 4 times -2i is -8i. 9i times 6 is 54i. 9i times -2i is -18i squared. And remember, I squared can be replaced with -1. So -18 times 1 is actually, or -1 is +18. Now we're going to combine like terms. So 24 plus 18 is 42. And then -8 and +54 is 46i. All right, so let's try this again. Let's go ahead and do our FOIL. So it's -3 times 7 is -21. -3 times 4i is -12i. 12i times 7 is 84i. And then 12i times 4i is 48i squared. Replace the I squared with the -1. And these are just getting dropped down. And then so we know that this piece here is really -48. So -21 and -48 is -69. And then -12 and +84 is 72i. And remember, the I piece always goes in the back. That's why it's just because that's the way a complex number is formed. All right, so is the product of a plus bi times a minus bi, where a and b are real numbers, a real number or an imaginary number? Explain. Okay, well, let's just try it and see what happens. So if we're going to FOIL this out, we'd get a times a, which is a squared. Then you'd get a times bi. Then we'd have a plus a times bi. And then we'd have -b squared times I squared. Well, these guys are opposite, so they would cancel. I squared is going to get replaced with -1. A squared is just going to drop down. This is going to times this is going to go positive. So a squared plus b squared. We only have real numbers, so we know that this has got to be a real number. So I would say a real number. Oops. Okay. So we're going to go ahead and multiply these. This is a good time for you to pause the video and try these on your own and then go back and check it to make sure you understand it. All right, so I may not show the same steps that they were making us show before here. So 6 times 3 is 18. 6 times -10i is -60i. -5i times 3 is -15i. -5i times -10i is +50i squared. That right there, we know the I squared is better known as -1. So I would just cross that out and write -50 above it. Just swap my sign. 18 times, or plus -50 is -32. -60 and -15 is -75i. So I got it down to 2 lines. All right, we're going to try it again. So 8 times 11 is 88. 8 times I is 8I. 15I times 11 is 165I. You can use a calculator, that's okay. And then we've got 15 times I is 15I times I is I squared, which is better known as negative 15 because the I squared is negative 1. We're going to combine like terms, so 18 and negative, or 88 and negative 15 is 73. And then 8I and 165I is 173I. All right. So this next part I think is actually kind of fascinating because it's an actual real life example of where this is actually used. And it is used by electrical engineers. I've always known that, but I've always never really seen a good application of it. This is a really good application of it. So electrical engineers use complex numbers when analyzing electrical circuits. An electric circuit can contain 3 types of components: resistors, inductors, and capacitors. As shown in the table, each type of component has a different symbol in a circuit diagram, and each is represented by a different type of complex number based on the phase angle of the current passing through it. Okay, so they show you the symbol for resistor. So this one here would be the resistor. And we know that that's a real number. Okay, an inductor. This one here is the inductor. And those are not standard names. I'm just using the first and the letter. And it's an imaginary number. Look, where it's B is positive. So it's a positive imaginary number. The capacitor is this one here. And then that's a negative imaginary number because it says that B has to be less than 0. The diagram of an alternating current or an AC current electric circuit is shown along with the impedance. The impedance is measured in ohms. The impedance is the number and the ohms of each component in the circuit. An AC power source, which is shown on the left of the diagram, this is the AC power source, and labeled 120 volts for 120 V for volts, causes electrons to flow through the circuit. Impedance is a measure of the component's opposition of the electron flow. That might not be a bad definition to know. It's not letting me. There we go. Okay. So we already said that this is the resistor. This one is the inductor. And this one is the capacitor. All right, use the diagram of the electric circuit to answer the following questions. The total impedance in this circuit is the sum of the impedances for the individual components. What is the total impedance for the given circuit? So we're writing the impedance for each component. So they said for the resistor, it's just a whole number. It's a real number, so it's 4. For the inductor, it's an imaginary number that's positive. So the number here with an I in front of it, or an I after it. This one here for the capacitor, it's an imaginary number that's negative. So negative 5I. And then we just find the sum by adding them up. So we add 4 plus 3I minus 5I. So this one stays a real number. And these two get combined together. So 3I minus 5I is negative 2I is the sum of the impedances. Excuse me. Ohm's law for AC electrical circuits says that the voltage measured in volts is the product of the current and the impedance. So voltage, and that's interesting. Now you've always seen voltage like on batteries, but the product is, so it's the product, the current, and the impedance. We're going to multiply those two together. So that's the other thing that we've done. So voltage equals I times Z for the given circuit. The current is this, which we just calculated. What is the voltage for each component of the circuit? So we're going to take that. The voltage for the resistor is 24 plus 12I. And if we went back and looked at the picture again, the impedance for the resistor is going to come from this 4 right here. So the numbers here, or the impedance that we calculated before, is going to be multiplied by all of those. So the impedance for the resistor was 4, and all we're going to do is distribute in that 4. So 24 times 4 is 96. 12I times 4 is 48I. So that would be the voltage for the resistor. The impedance for the inductor was 3I. All right, we're going to distribute that in. So it's going to change things around on us a little bit, okay? 3I times 24 is going to be 72I. They're going to put that at the back. And then 3I times 12I would be 36I squared. Remember, I squared is -1, so that's better known as -36. Then the voltage for the capacitor, the impedance for the capacitor was -5I. So when I'm going to distribute that in. So 24 times -5I is -120. -5I times 12I is -60I squared. And remember, I squared is the same as -1, so that's better known as +60 because -1 times -60 is 60. All right, so we're going to reflect on this. To find the sum of the voltages for the 3 components in part B, what do you notice? Okay, so let's actually add up the 3. So they want us to add these 3 together to get the overall voltage, okay? So I'm going to write those down. So we've got 96 plus 48I plus -36 plus 72I, and then plus 60 minus 120I. You could put parentheses in there if you wanted to separate each number, but that's not necessary. All right, we're going to combine like terms. So 96, -36, and 60 is going to be 120. And then 48, 72, and -120 is 0, actually. So that kind of goes away. So all we have is the real part. So you'll notice that it's actually a real number. Oh, and if you also go back and look at the picture, just want to make sure I'm not missing parts. The sum of the voltage of the parts is actually the voltage overall that's there, okay? So let's write that down. So the sum of the voltage the voltages equals the voltage supplied by the power source. Okay. All right, so we're going to try one more of these. Suppose the circuit analyzed in example 4 has a second resistor of impedance of 2 ohms added to it. Find the total impedance given that the circuit now has a current of 18 plus 6I amps. Also find the voltage for each component in the circuit. All right, so we're going to kind of do the steps again. Basically what they're saying is we're going to take this old impedance and we're going to add in another circuit that is, they're going to add a second circuit in there of 2 ohms. So basically we're just adding 2 ohms to this thing here. So we're going to write it out. So it is 2 plus the 4 that was there originally plus 3I minus the 5I. So that was all the stuff that was there before. We're just going to combine like terms like we did before. So 2 plus 4 is 6. And then 3I minus 5I is -2I. All right. Then we've got to find the voltage for each component, each part. So we need the voltage for resistor, first resistor, second resistor, inductor, and the capacitor. All right, and our new current is this. So we would take our 18 plus 6I, and we're going to multiply it by our impedance there. They're saying it doesn't really matter. You pick whichever order. But the original resistor was 4. So we're going to use this 18 plus 6I on all of them. And then my second resistor's ohms was 2. My inductor was 3I. And my capacitor is negative 5I. All right, so we're going to go ahead and distribute on each one of those. So distribute that in. 4 times 18 is 72. And 4 times 6I is 24I. Distribute in the 2. 18 times 2 is 36. And 6I times 2 is 12I. Distribute this in. 18 times 3I, we're going to automatically put to the back because it's an I, is 54I. And then 3I times 6I is 18I squared, which is better known as negative 18, because the I squared is negative 1. All right, I'm going to distribute this in. So 18 times negative 5I is negative 90I. And negative 5I times 6I is negative 30I squared, which is better known as positive 30 because I squared is negative 1. All right, that finishes up what we've got to do today. You guys need to finish up your points for the day, you need to answer discussion number 16. And then go ahead and work on the posted assignment.